On February 16, 2007, a massive fire broke out in the propane deasphalting unit at the Valero McKee refinery near the town of Sunray in the Texas Panhandle. 3 workers, including a contractor, suffered serious burns. 11 others received minor injuries. The fire occurred after liquid propane was released from process piping in a deasphalting unit. The rapidly spreading blaze forced the evacuation of the entire refinery.
The CSB investigated because of the serious nature of the accident. The fire shut down the refinery for 2 months, and it operated at reduced capacity for nearly a year. The shutdown contributed to temporary shortfalls in gasoline supplies in some markets.
The fire caused extensive equipment damage. Valero estimated that direct losses exceeded $50 million.
Our investigation found several key factors combined to cause this damaging fire, which in turn led to 2 near misses that could have been catastrophic.
The following animation depicts the sequence of events the CSB determined likely led to the accident. The propane deasphalting unit, or PDA, used high-pressure liquid propane to separate asphalt and gas oil from a heavy petroleum mixture known as pitch. Propane flowed through a control station, up a vertical pipe, and into an extraction tower. When the process was originally designed, propane also flowed through a second control station, mixed with pitch, and entered higher up on the same extraction tower. But in the early 1990s, the process was changed, and the use of this second station was discontinued by closing several valves. This created a dead leg, a section of piping without any flow through it. The CSB later determined that, unknown to operators at the time, a foreign object, a piece of metal, had wedged under the gate of one of the 10-inch valves, preventing the gate from closing fully and leaving a path for liquid to seep past the valve. The propane above the valve contained small amounts of water. Some of the water, which is heavier than propane, sank through the valve and accumulated in the piping elbow below.
The piping dead leg formed by the mixed control station had been left connected for years, apparently without incident. But now, in February 2007, conditions arose that would lead to a pipe failure.
That month, a cold snap dropped temperatures well below freezing for 4 days, reaching a low of 6 degrees Fahrenheit on February 15th. Water in the piping likely froze, expanded, and cracked the piping elbow. For a time, the ice itself prevented propane from escaping, until around 9 a.m. on February 16th, when the temperature climbed above the freezing mark and the ice began to thaw. At 2:09 p.m., the melting ice gave way. High-pressure liquid propane from the deasphalting unit began to escape through the small opening in the leaking valve and out the cracked elbow. The CSB estimated the initial flow rate of propane at 4,500 pounds per minute. A large flammable vapor cloud rapidly formed. The wind blew the propane cloud toward a boiler house. Moments later, the cloud ignited. Flames flashed back to the cracked piping elbow, creating a high-pressure jet fire. The fire rapidly damaged nearby pipes, causing a second jet fire aimed at a non-fireproofed steel support structure under a pipe bridge 77 feet away. Within minutes, it collapsed under the intense heat. This broke open numerous lines filled with flammable materials flowing from other parts of the refinery. The growing blaze threw massive fireballs and thick black smoke into the air. A surveillance camera captured the spreading fire. The alarm was activated at 2:10 p.m., a minute after workers heard what they described as a popping sound from the first propane release. The refinery's emergency response team attempted to turn on stationary firewater monitors, but shifting high winds hampered their efforts. 15 minutes after the fire erupted, managers ordered the total evacuation of the refinery. This decision may have saved lives, because the large extractors full of propane might have failed catastrophically, or the fire could have affected nearby units that contained other hazardous materials.
The The CSB investigation identified shortcomings in process safety management at the refinery and disclosed gaps in industry guidance on safety equipment and practices. The CSB issued recommendations to the American Petroleum Institute, the company, to the McKee Refinery, and to the United Steelworkers and its local.
This accident began in a section of liquid propane piping that hadn't been used for up to 15 years. At the time when its use was discontinued, management did not conduct a review to determine the safest way to take the piping out of service.
Closing the valves in the control station created a dead leg, a section of piping without flow. The CSB found that the safest approach would have been to permanently remove the section of idle piping, but this was not done. Nor was the piping elbow positively isolated from the source of high-pressure propane using a blind, a metal plate inserted into a pipe flange. Freeze protection could also have prevented the water-filled elbow from fracturing during cold weather.
Freeze protection practices at the McKee Refinery were informal. There was no written program in place to ensure that all equipment that needed freeze protection necessarily got it.
The CSB report noted that the American Petroleum Institute, API, does not provide any detailed guidance for refineries on establishing effective freeze protection programs. The board recommended that API develop a new recommended practice for refinery freeze protection, which should include the establishment of a written freeze protection program, periodic inspections of dead legs and equipment that is infrequently used or out of service, requirements for management of change reviews.
Jet fires are difficult to fight, and the best approach is to stop them by shutting off their fuel source. The best approach to doing that is to provide remotely operable emergency isolation valves that can be quickly actuated from a safe location to shut off that fuel source.
The CSB found that American Petroleum Institute guidance does not specifically discuss the use of remotely operated shutoff valves in refinery process units to control jet fires. Valero's internal standards do require remotely operated shutoff valves, but at the time of the accident, the company had not retrofitted such valves into the de-asphalting unit at the McKee Refinery. When the initial release occurred, control room operators could not shut off the flow of propane.
Another very useful approach is to fireproof piping, equipment, and support steel in the area so that it doesn't fail quickly when first exposed to a jet fire.
During the incident, a high-pressure propane jet fire shot toward the support for a 90-foot wide pipe bridge. The support was not fireproofed and quickly gave way. Fireproofed pipe rack columns, however, remained intact throughout the inferno.
Not fireproofing the steel structures that support pipe racks makes them susceptible to collapse in the heat of a refinery fire. When these pipes do collapse, more liquid can be released, feeding the fire and increasing its intensity. The collapse of the pipe rack at the McKee Refinery also contributed to the extended shutdown of the facility.
The CSB found that API and Valero safety standards recommend fireproofing structural steel supports up to a maximum of 50 feet from possible fuel sources. But CSB investigators observed damage to the pipe bridge support 77 feet from the likely source of the jet fire. The CSB's final report called on the API to revise its fire protection guidance to require the use of remotely operated shutoff valves and more extensive fireproofing of structural support steel near refinery process units where jet fires can occur.
Valero used chlorine as a biocide to kill bacteria in cooling water. This chlorine was stored in a hazardous area where it was exposed to the threat of fire. Refineries don't have to use chlorine. There are inherently safer chemicals, such as bleach, that can be used for this purpose.
3 one-ton chlorine containers were in a shed only about 100 feet from the de-asphalting unit. The intense heat ruptured one of the containers and melted the fusible plugs on all 3, causing a release of chlorine. Valero reported subsequently that more than 5,300 pounds of chlorine were released to the atmosphere. The toxic gas could have presented a serious threat to responders had they not been evacuated earlier. A second catastrophe could also have occurred. Northwest of the deasphalting unit were 4 large spherical tanks filled with LPG, or liquefied petroleum gas. The closest tank was exposed to heat from the fire.
The paint on the outside was blistering, but operators could not turn on the water deluge system to cool the sphere because the water valve was located too close to the unit where the fire was raging.
Had the wind shifted and driven flames toward this sphere over a prolonged period, it might have failed, releasing up to 151,000 gallons of highly flammable pressurized butane. Emergency responders told CSB investigators they were particularly concerned about the danger from the butane sphere because Valero had recently held a commemoration for a deadly explosion that occurred 50 years earlier at the same refinery, then owned by Shamrock Oil. In that accident, fire caused a spherical tank of pentane to suddenly explode, killing 19 firefighters. The refinery's process hazard analyses had not evaluated the risk of storing chlorine near flammable hydrocarbons, or the possibility of a fire in the deasphalting unit affecting the butane sphere. The CSB report also noted that API standards do not require refineries to evaluate hazards from nearby units when locating firewater deluge valves. The board called on the API to revise its guidance for liquefied petroleum gas facilities to ensure that deluge systems can be activated during emergencies. The CSB also recommended that Valero follow its existing plan to replace chlorine with safer biocides for cooling water. Finally, the CSB called on the McKee Refinery, the United Steelworkers, and its local union to work together to improve the hazard analysis program at the facility.
Safe petroleum refinery operations can benefit not only workers and companies, but the nation's economy as well, preventing outages and shortfalls in the nation's vital gasoline supply system. Thank you for watching this CSB safety video. For more information on the CSB investigation report on the Valero refinery accident, please visit csb.gov.